my name is Matt Lord, and I'm going to be talking to you about Vitess VReplication. I work at PlanetScale, and so if you haven't yet been to the booth, please come by. I'll be there most of the time, so I can talk about Vitess, and we'll be happy to talk about PlanetScale as well. And the features that we're going to be talking about are actually leveraged in the PlanetScale for all of the cool features that we can show you. Just out of curiosity, who's using Vitess or has used it in the past? A couple people? Okay, good. Is there anybody in the process of evaluating it or thinking about it? All right. So hopefully this will be interesting and useful to everybody. I'm going to dig in a little bit about, first we'll just cover Vitess and just give you a brief overview. So even if you have used it a little bit, you may find some interesting things in there. But I think it should be really helpful for people that haven't used it yet to give you some context about Vitess to lay the groundwork for when we dive into VReplication specifically. And then we'll end with kind of just what's recent that's particularly of interest to people that have used Vitess in the past, or if, even for people that are considering it now or have maybe recently looked, there's a few things on there that are even more forward-looking. Looks like you can see that okay. So Vitess is an open source project. PlanetScale is a company that's formed around it to build a serverless database offering. Vitess is really at the heart of it. And Vitess is a CNCF graduated project. So if you remember earlier from Peter's talk, if you were there for his keynote and the slide for all of the Cloud Native Computing Foundation projects, Vitess was one of the myriad of logos that you would have seen up there. And it's Apache licensed. It's written in Golang. And one of the cool things about it, this is the beauty of open source, is that users of Vitess, so for example, Stripe, and they added group application support just as one of the big features they've added. And Slack has added a bunch of stuff. They're working on a VT admin and doing a lot of work on that, which is another new feature. So it's really a community that's built up around it, and the users, many of the users are also significant contributors. HubSpot is another one. A couple of people here from HubSpot, and they've made some contributions as well. It's cloud native in this, and again, this ties back into Peter's slide. So what does that mean? It means it's grown up in the era where people don't expect to be ordering Dell machines, for example, and bringing them in and putting a hypervisor on it and running VMs. They expect it to be quite fluid, to be able to automate all the orchestration easily. So that's where Kubernetes comes in. Vitess grew up along with Borg at Google. So Vitess was originally started at YouTube. Google bought YouTube, and so it grew up with Borg. Borg was the Google product, or that ended up becoming Kubernetes when they open sourced it. And so it's always been in that context, and so it has a very native Kubernetes design model. So the things that it values, the way that it's designed, kind of the model of the code base and the way that it operates is all very familiar if you're used to Kubernetes and the things that operate in that space. It has a Vitess operator, and if you're new to Vitess, or even if you're running Kubernetes, that's definitely the best way to go. It makes it easy. Obviously, there's a bit of a learning curve with Kubernetes, but if you already have Kubernetes up and running, the operator is quite easy to install, and it actually makes it very easy to operate Vitess. So that's definitely the way to go. If you want to just kick it on your laptop, there's also a tutorial that will walk you through using Minikube directly on your laptop. That's also a good way to just try it out. It supports MySQL 5.7 and 8.0. Historically, it also had support for MariaDB, but that's dwindled since 10.3 as MariaDB diverged more from MySQL. And so actually, we're likely going to deprecate official support for it, MariaDB, in the next release of Vitess, so 14.0. That could change in the future, but it's just become a significantly enough different database that it just will prove to be a big challenge to support two different databases in Vitess. Eventually, if we do support two different databases, I think more likely it would be Postgres, only because like every day, literally, we get people asking us about Postgres support. And that's by far the most upvoted GitHub issue in the project as well. So if we did go through the effort of really supporting 2 different databases at the top tier, it would most likely be Postgres at this point. This is just some of the users that we have of Vitess that have been in production for quite a period of time. And as I mentioned earlier, these are also people that are not just users, but they are part of the ecosystem. So they're also big contributors. So as I mentioned, Slack has done quite a few things. The latest VT admin, they really led the charge on that. And that's kind of a new graphical user interface for visualizing your Vitess topology, administering it, and so on. So all the stuff that you can do from the command line, you can also do from this graphical interface, and you can pick which one you prefer. So a little bit about the concepts. So in Vitess, there's a concept of a key space. And a key space is just a kind of a larger abstraction on top of a database. So normally, if you spin up a MySQL instance or a Postgres instance, you have your database or a schema. In MySQL, those are the same thing. And in Vitess, a key space is just a logical construct that, because you are sharding your databases in many cases, so you don't just have one MySQL D instance with my customer database on it. Your customer database is actually spread across 10, 20, 100 different MySQL instances and partitions of that data set. So the key space is that logical concept that spans this. So you would still, when you connect to Vitess, as we'll get to in a bit, you would say use customer, and then you would run whatever queries you normally do. And so what you're using there in Vitess lingo is the key space. So that's just the logical database in Vitess. And then a shard is a subset or partition of that data. So let's say, when Vitess is typically interesting, or when it comes into the picture for most people, is they've vertically scaled as far as they can. Right? You get a bigger physical machine, you get a bigger VM, and you add more memory. You get NVMe disks and so on. And you just keep scaling up until at some point you realize off in the horizon, we're not going to be able to scale up anymore. And then that's when you get into kind of partitioning or sharding your data set. And that's where Vitess becomes interesting. I think what makes Vitess particularly interesting is that it is, as we'll see, on top of MySQL. So you still have MySQL instances. So you can still back them up the same way, monitor them the same way. Same administration and operations concepts. So it's a bit easier than moving to one of the 100 different MySQL compatible offerings that are out there. TiKV being one example, I think it's an interesting concept. It's a great product, but it's also not MySQL behind the scenes. So if you're running it yourself, it's cloud service, you don't care. But if you're running it yourself, that's one of the strengths of Vitess, is it really just builds on that and glues all those MySQL instances together. The last kind of major concept is a cell. So it's really a failure domain. That's the Vitess specific terminology for a failure domain. So typically that would be a data center or an availability zone. It could even be a rack, but really it's some discrete failure domain that where you want to be able to sustain failures across one or more of those domains. So you split up your resources across those, in Vitess speak, across those cells. Okay, so this is what you would probably have. So let's say you've been scaling up and up and up, beginning bigger machines, adding memory, faster block devices. And you have something that looks like this. So you have your primary instance. That's where all your writes go. And then you have replicas, which you may send reads there to scale out reads. But if nothing else, it gives you some redundancy, gives you additional servers that you can fail over to if something happens on the primary for maintenance and so on. So this is what you would typically get to. And then when Vitess comes in, it's not much of a change. The biggest change is that now each of these hosts, so let's say these are on discrete VMs. Let's just keep that simple, because if you're just getting in, good chances that's kind of the model you're on. If you're in Kubernetes, it'd be pods instead. But now that there's a process called a VT tablet, and that's really what makes each of those MySQL D instances part of Vitess. So really, Vitess is going to be interfacing, for the most part, with those tablets. And the tablet is what manages that MySQL D instance. So it will start and stop the instance. It does connection pooling in front of them. And we'll do query consolidation. So if you have, let's say, Justin Bieber, I think that was the classical Facebook issue. It was like Justin Bieber posts a new picture on Instagram, let's say, and you just have a million people, boom, suddenly contending for the same record. Hopefully you have a good cache in front of it. Facebook does. But if you're effectively using the database as a cache as well, that's going to create a huge influx of queries against the database. So just as an example of something that the tablet does, is it will consolidate those. If it sees them all come in where they would get the same read view in the database, it will consolidate those in the tablet layer. It runs the query once in the database and then returns that result up the stream to everyone that had requested it. So it's just a nice way to alleviate load on the MySQL D instance and manage it as a component of Vitess. So most people, again, will have several databases or schemas. So your customer database, your products database, for example, and so on. And you would continue to have that with Vitess. Remember that these are key spaces, but otherwise it's the same concept, right? So you have your, let's say, your customer database, your products database, your analytics database, whatever it may be. And now that you have multiple key spaces, right, how do you access it, right? So normally if you actually do have a customer database and a products database, you might have something in front of it like proxy SQL, which would then give you a single endpoint for your applications to talk to. Or your applications just know, like, OK, I've got to talk to this other endpoint because that's the customer database. So a lot of that complexity, or really all of that complexity, is hidden in Vitess by a process called the VT gate, or the Vitess gateway. And that's a stateless proxy, so it's easy to scale up. You could have 10, 20, 100, 1,000 of these per cell, let's say, typically. So you'd have, typically for your traffic, just as you would outside of Vitess, you'll have some affinity based on your cell in Vitess or your AZ. So the traffic will always stay within a certain data center or AZ when possible. So that's a typical way to scale it up. So you have a load balancer by your cloud provider, which then round robins requests to the VT gates in that AZ. And then the VT gates are what really present all of your databases to the applications, to the MySQL CLI, and so on. So it speaks the MySQL protocol. There are rare cases where you'll realize it's a little different because obviously it's not a single MySQL D instance. So for things like for performance schema, for example, if you're querying those tables, or some specific feature that just came out, like some windowing functions, for example, in MySQL 8. So Vitess doesn't yet have support for that. So that's an example of where you would see something, even though you may be using MySQL 8, where the application would see a difference when talking to Vitess. And if you have any questions along the way, please feel free to ask. We lost 10 minutes, but I would say that in most cases, it's probably even better to just grab me afterwards. I'll be down at the booth. I'll be hanging out, and I'd be happy to answer any questions you may have. Any questions so far about what the topology looks like that maybe, if you think it may be helpful to everyone else? Hopefully this makes some sense. Again, it's really building on the basic MySQL infrastructure that you likely already have in place. The main thing is it allows you to split up or shard a given data set and then access it from the application side and from the CLI just as if it wasn't unsharded. That's the main thing that it gives you.
Uh-huh. What can you, it sounded like from your description that you implied that you can actually route queries to multiple shards. Under what circumstances would you do that?
Well, what I primarily meant by that is normally your application is going to be, so it will be talking to multiple databases, right? So let's say you had your customer database and your product database. So your application is going to say, use customer and then run a query, or put, select star from customer dot table 1, right? So that's what I mean by it will route your queries to all the different key spaces. It does support, so you would ideally want to query a single shard so that you have full data locality there for all your queries coming in, and we'll get into how that works. But there are some cases where you may need or want to do a scatter gather query, and that that will also happen here. So let's say you just want to select every row in your sharded table, for just as a simple example. The VT gate will also support that. It does a scatter gather query, so it will pass that query on to to both of the shards in this commerce example, and then aggregate the results before sending it back to the client. And we're going to just talk about next really quickly how this actually works. How much? I have till 3:20? Okay. I want to make sure we have time to actually talk about VReplication, which is the main thing. But of course, this is important to know to really kind of fully understand the importance and the value and kind of get your ideas flowing in your head about how all this stuff works and the value that VReplication can bring. But how this works is you have our key space called commerce. So these are queries coming in from the application. Again, they'll connect to a host and a port, and it'll appear to the client to just be a MySQL instance. They would use that. And again, the commerce database is sharded. But they run this query, and they specify a customer ID. And in Vitess, you would say, this is what I want my primary V index. So in Vitess, you'll see a lot of VT foo. So that's like Vitess technology, and then the Vitess technology. For stuff that's similar to a MySQL concept, like an index, you'll often see just a V in front of it. So a V index or a Vitess index is just a way to declare, for example, that this is what our shard key is going to be on. For the customer table, the shard key is going to be customer_ID. And so when that query comes in, the VT gate will run a hashing, whatever hashing algorithm you specify to build a hash, and then it will know from that hash which shard it should go to. So it's going to be a 16-digit hexadecimal number or base 16 number, and it will resolve to something that's in that range. So this is all zeros, so 16 zeros to 8 and then 15 zeros. It actually goes up to, so it's actually, this one is 7 and then a bunch of 9s, and then this one is 80 all the way till the end. And so for that particular number, with the default v-index function, it resolves to D2FD, and then it keeps going. And so we know that that's actually going to be, that row is going to be here. So for your insert, it would get routed there. For your select, it would get routed there. But all of that happens behind the scenes. And there's a number of different v-index functions you can specify, but they have different pros and cons. A lot of it has to do with the data type that's used as well, but they all will produce a deterministic hash so that it can be used to route all of your queries. You can also query, so by default, I keep switching back and forth. I don't have a pointer, unfortunately, so sorry, I'm kind of blocking this. But by default, all of your reads and writes are going to go to the primary for however many shards are involved. But you can also target replicas. So at the end, where you have this use, you could say use at, or use commerce at replica. Let's say if you explicitly wanted to use your replicas for scale out, you can do that as well. Today we don't have automatic read-write splitting. So what you would do is you connect to the same endpoint. If you want to query your replicas, you can say use customer at replica, and it'll get round robin. Your request will get round robin to all the replicas. One key service, and I'm going to have to speed up a little bit so we actually have time to talk about this, but another thing that you'll see that's a core part of Vitess is the concept of a topology service. So if you're familiar with Kubernetes, you'll know about etcd's role in Kubernetes. And the topology service serves that same basic role in Vitess. So that is where kind of the metadata about the cluster is defined. So all of your key spaces, the shards for your key spaces, and so on. But that's also the coordination service. So as all of these pieces need to coordinate, so they will typically coordinate through the topology service, which happens to use etcd by default as well, just like Kubernetes. So they will lock a resource. So let's say if you want to make changes to your shard topology, you would lock that shard in the topology service or the locking service, and then that will block other components within Vitess from making changes to it at the same time. VT-KITTLE-D, this is kind of the main way that you would perform operations. So let's say you, as we'll talk about shortly, if you want to reshard your data, or you want to perform a failover, so plan to reparent shard is that command in Vitess. So let's say you wanted to take this one out for maintenance, you would use the client, VT-KITTLE, and tell it you want to do a plan to reparent shard for that shard, and then the Vitess control daemon is what would actually reach out to the tablets and perform all those steps in a safe way. VT-admin, I mentioned already. That's the new graphical interface that will allow you to do all these same kind of things. Under the hood, it's going to be using the same servers, the same daemons to actually perform the operations, but then it'll give you a little nicer interface so that you don't have to remember. If you're new to Vitess, you don't have to remember, oh, planned, reparent, shard. It'll be just a more natural interface. I'm going to skip over this one, but this just reiterates what I mentioned before, in that a typical setup is you would have, let's say you're in GCP or AWS, you have your load balancer from the cloud provider. You would have that in each AZ, or potentially each region if you're in multiple regions as well. And then those load balancers will round robin, by default anyways, requests. So they'll distribute requests to all the endpoints that you've associated with that. And those endpoints will then be VT gate instances, which is what provides that MySQL interface to Vitess. Okay, that was a lot. I wish I wouldn't have lost that 10 minutes. I'm trying to talk fast, so I apologize. But again, I'm more than happy to have offline discussions after this. So, one core component about Vitess is VReplication. So if you think about this, you might have 1,000 MySQL D instances that are participating in a Vitess cluster, a Vitess installation. So how are you going to replicate between these? So when it comes to just those replica sets, which become a shard basically in Vitess, where you have your single primary and 2 or 3 replicas, where that's actually just standard MySQL replication within that shard. But what do you need to do if you want to then, let's say, take this unsharded key space? It's not technically always just one shard, not unsharded, but you want to take that and you want to split it into 2. How are you going to replicate that data from the single shard into those 2 smaller shards? So we're going to talk about that. But I think it's important to also keep in mind that it's really a set of primitives and building blocks that you can use for constructing a lot of different complex data streams. And we're going to highlight some of the main ones, but I just wanted you to keep that in mind, that it's a very reusable, there are reusable components that can be changed, altered, built upon, combined in different ways to do a lot of things that it doesn't do today yet. We're constantly adding new things. So online schema migrations, which PlanetScale leverages, is probably the most recent example. So remember I said the most common pathway into Vitess is that you've been scaling your database up for as long as you can, right? And realize if you're not already at the biggest machine, you're trending towards it, and at some point you're going to need to horizontally split your data. And it could be for any reason, but you realize that need is on the horizon. And this is actually a pretty common use case. This is something that, for what it's worth, PlanetScale makes quite easy, especially for the RDS example. You just point PlanetScale at your RDS instance, and it will actually leverage VReplication in this same way to help you migrate into PlanetScale. But this is what's getting used underneath the hood. So you would add a tablet. So this is an unmanaged tablet, meaning that the tablet isn't actually managing your RDS instance, right? RDS does that for you, so it's not starting and stopping the instance, for example, but it just allows us to interface with that RDS instance as if it was a Vitess component. And let's say we've already created the Vitess infrastructure that we want. So we've said, for now, we're just going to split it to 2 shards. You don't really need to, you can shard as you go. So you can go from 2 shards to 4 shards, as we'll see. And so there's not really any reason to go beyond what you need in the short to medium term. So let's say you need to go 2. So what you would do is you would, after putting this tablet in place, so that's what allows us to communicate with that other database instance. So from there, oops.
Sorry, quick question. What's row streamer versus binlog streamer?
Yeah, that's what I was just getting into now. I was just trying to make this a little, just change the size a little bit. Okay. Yeah, I know, sorry. I keep forgetting how delicate it is. So we've gotten to this point, and we run a command. So you would say, use the move tables operation. So this, you say vt-kittle move tables, and you'd say, hey, I want to move just, in this case, we want to move all the tables. But you could move one or two. So let's say you're already in Vitess, and you just want to do, you want to vertically split them. So you realize, hey, these set of tables can logically form their own unique database or schema. And so you split them out. But in this case, oops, I went one ahead. You run that, and then what happens is it goes through a cycle. So there's VReplication will first start a copy phase. And so that's where this row streamer comes into play. So now the row streamer will basically, the easiest way to think about it is very similar to it if you had done a MySQL dump on this particular side and you streamed that to the other side. In effect, that's essentially what it does. So it will connect. It will. So let me go this way. I use this as a pointer. It will connect. It will do a start transaction with consistent snapshot. So now it's going to have a consistent snapshot that can use to copy a big chunk of rows. So by default, this cycle will go in 1 hour cycle. So if it's a relatively small table, it'll just happen once. It will lock the table briefly just to get a GTID snapshot. So it says, OK, I have this consistent snapshot, this read view in InnoDB. And now I know the GTID executed snapshot that goes along with it. Same thing that MySQL dump will do. And then it runs a select star and starts streaming all those rows. So in this case, the target tablets are the kind of the coordinators. So the vt-kittle-d will send the request to, hey, we want to do a move tables operation. And what it actually does is it inserts a record into the underlying system table. So there's an underscore vt.VReplication table. And it actually inserts a record into there. And the tablets are regularly polling that and say, oh, there's an operation, a VReplication operation that we should be doing. And then it will kick that off. And it looks for a tablet on the source side in order to replicate from. In our case, of course, there's just one. But normally, you could have a sharded database on the source side, or you could have a number of replicas as well. So you can configure what its preferences are. But it will pick a source tablet and kick all that off. As the rows are streaming in, they're being applied. So on the source side, you have this concept of a row streamer. And as you can guess, that's sitting there streaming rows. So on the target side, it's processing those rows just like any a normal MySQL client would. And it'll continue to do that for up to an hour. And let's just say at this point, within that hour, we've finished. We've copied all the rows. So we've reached the end of our select star, right, from table. We've read all the rows. And now we'll switch over to the running mode. So in the running mode, that's where what the binlog streamer is. So this is where it will, this tablet will connect to its source just like a normal MySQL replica would. So if you're familiar with that, in the MySQL protocol, there's a com binlog dump gtid command that the replica runs. And it just says, hey, these are my gtids that I've executed. And then the source says, OK, well, I know you need everything else I've executed that's not in that set. And so then it starts getting all those events. And it does 2 levels of filtering on this unmanaged tablet side here. So the first is it's going to say, OK, does this binlog event apply to a record that we've actually copied? So if you've got a large table, it could take hours, it could take days to copy. So it'll go through multiple cycles. And if this binlog event doesn't apply to a record we've copied, then we don't care, because we're going to later get a newer version of that row anyways. So I'll throw that aside. Otherwise, if it is one it's copied, it will look to see which shard it should go to, and then it will forward that onto the target side. Now on the target side, you've got the vcopier and vapplier components, which essentially you can think of them as acting like the IO thread and SQL thread. that you're familiar with in MySQL. So that's where the title comes from, standing on the shoulders of a MySQL giant. As you're seeing, we're leveraging all these same concepts and these same technologies that normal MySQL replication uses. So it actually stores it in a relay log and then applies it in the same way that a normal MySQL replica splits up those particular pieces of work. The main difference is that the bin log events are not applied directly. So we use row-based replication, but we don't actually apply them directly. We turn them into SQL statements because it's quite common to have a different schema on the target side than you had on the source. Could be simply because you're sharding your data set, or it could be just that now you're taking the opportunity to change a column name or add a new field, remove a field, so it gets turned into SQL statements so that we can then map kind of the columns on the source side to the columns on the target side. That was a lot, I know, but hopefully you're starting to get a feel for the basic components involved and how they work. Any quick questions on that? Because the rest of the stuff we're going to talk about really builds on that. Another thing to take away is you see these two specific types of streamers. So the event streamer is actually what's used there. It's just a modification of the basic bin log streamer, which will do kind of batching and pipelining, a number of other things because we don't externalize intermediate states. So normally if you're using MySQL replication, it externalizes the states as it goes. Right? So it will, by default anyways, apply everything in the same order so that you don't get an inconsistent read if you're looking at the replica. But in Vitess, one thing that we'll talk about a little bit more is, hopefully, is the concept of routing rules. So even if you intentionally try to query this LeetDB side while we're in this process, it will redirect or send your queries against the OKDB side. So you're not ever actually able to query this data until you get later on in the operation and you say, okay, everything's good, and I want to switch traffic. But the basic building blocks is called a vStream. I just wanted to point that out. So we're going to be building on that same basic concept. The row streamer is an adaptation on that. The bin log streamer. There's also result streamer and some other ones.
Quick question. So are you using the MySQL replication applier on the destination?
So on the primary, sorry, I wish I had a pointer, but the primary is where the Vitess components are, so the vCopier and the vPlayer. But then from there, within that shard, it's just normal MySQL replication.
So then do you not have to worry about the order in which you apply those bin log events, and whether or not the order in which you apply those bin log events is
Yes.
enough to keep up with the actual error rates?
So the order is important, but what I mean by that is kind of it only has to be transactionally consistent. And so actually MySQL replication also has options to where you can improve the performance of replication if you allow it to, if you're not externalizing reads in the same order. So what that allows Vitess to do is to do a bunch of batching and pipelining. So you might have 1 million transactions that each update one row. So those can be batched into what's called a vStream packet and get sent along. As long as they're executed in the correct order and we are eventually consistent, we eventually hit the state that we want, that's all we need to care about. So that just offers up opportunities for kind of batching and pipelining all of these requests that happen on the source side. You don't have to do them in the same kind of transactional context. Of course, they all need to be executed atomically in units so that you can roll them back or retry them as needed. But you can batch them up into whatever chunks you want.
Could you talk about the cutover? Like once it is done, how does it transition into total?
Yep. Yeah, so I'll cover that a little bit more. I hope I got, 50? I'm running low on time. Okay. So I lost 10 minutes to technical difficulties. But so I'll go through some of these pretty quickly. But the main thing I want you to take away from this is all the other use cases and commands are really all built on top of these same concepts and these same building blocks. They just work in variations of that. So one is kind of vertical sharding. So this is another use case where, as I mentioned before, you've got your, let's say you had everything in one key space or one database before. You realize, okay, the customers can live separately from the products, for example. And so you can do that. That's just one use case, really. It still works in the same way that we had talked about before. The main difference is, of course, now you're not moving all tables. You're just going to say, I'm going to move all my customer tables or order tables over here, all my product tables over here. Otherwise, it's the same. It's the same command that you would use. It works the same way under the hood. It's just really a different use case. This is the main one. So we already covered kind of getting data into Vitess, and that's really, this is just, again, an extension of that. So this is just shows resharding. So it's the same basic workflow. The main difference is when we were moving data into Vitess, or when you're going from an unsharded key space to a sharded one, and you're moving across that key space boundary. Right? So you're moving your tables from my key space 1 to my key space 2. In the case of a reshard, it's the same key space. You're just resharding that key space. But otherwise, it operates in the same way. But just to keep in mind that you can go from, it's normal to go from one shard. Like if you start off with one shard, that's normal until you need to split it. You can just have your particular database in a single shard, and you can scale up to 2 for, it doesn't have to be power of 2. It can be 7, 8, and so on. But oftentimes you would do it in power of 2. OK, so now we're going to get to kind of where it's completed and then what your next steps are. So VDiff is kind of typically the next thing you would run. So now let's say you've moved over 8 tables, it's 10 terabytes of data. OK. How do I know that I've faithfully copied all that over? So that's where VDiff comes in. So you can run a VDiff operation, and it will actually compare. We don't have time to get into all the details now, but I'm happy to talk about it afterwards. But it will compare the row by row on the source and target side, and then tell you at the end, okay, and it uses a consistent snapshot on both sides. And how it does this is interesting. I wish I had time to get into it, but I'm happy to afterwards. But basically at the end, it'll tell you, okay, based on this snapshot point, so it could take 2 days to run. So really it's telling you what it was when it started. Let's say, 5 minutes ago, it could be 2 days ago. But it'll tell you, okay, everything was the same. There was no extra rows on the source, no extra rows on the target, and no differences found in the rows that were copied. So that really gives you confidence. So now you go on to, and I'll have to skip through these, unfortunately, but the next thing that you would do is switch the traffic. So I'll get to this. I'll just skip through these kind of quickly. Materialized views, really this is another use case built on top of these. The main thing is that you're not actually moving a table, sharding a table or anything else. Basically, you just want to materialize the results of a query. A common use case I put up here is, let's say you sharded your big data space, but you have some lookup tables that you would still like to be accessible locally so that you have data locality for your queries. Or it could be some aggregated or transformed view of those tables as well. Then you can use materialized tables so that you have that view available locally in each of your shards. Online schema changes, we'd love to talk to you about that on the planet scale side. But this is another thing that actually, kind of the most recent use case and workflow that was added on top of VReplication. And it allows you to, remember, if you were at the online DDL talk on yesterday, this really addresses all of the issues that was raised there. So it allows you to, you can schedule them, you can monitor them, you can revert them, you can cancel them. It's idempotent, declarative, has like all the features you might think of. It was initially designed by Shlomi Nowak, who also created the GitHub Online Schema tool, which is, in my mind anyways, kind of the logical successor to PTOSC, which was the successor to the Facebook OSC. But this is, in my opinion anyways, kind of the state of the art for doing online schema changes. And Planet Scale just makes that very easy. You don't have to worry about any of the details behind it. Another one is messaging. The slides will be available, and I'm happy to talk about this as well. But this just allows you to to create a table with a specific structure and comments that then Vitess says, okay, there's a messaging table, and then other components can subscribe. You can use the SQL or gRPC to subscribe to changes. So it could be for CDC or any kind of offline processing that you want. Again, these are building blocks that you can do lots of interesting things with. So take that away. So if there's a use case you have in mind that's not met, just keep in mind that contributions are certainly welcome. And that doesn't have to be code. It can be a feature request. It can be a bug. Be happy to solve more use cases in Vitess going forward. We talked about these. It's just a bunch of safety mechanisms. VDiff2 is coming. Rohit, who's the other person that works on VReplication along with myself. We've been discussing that, and we'll have a draft PR of that shortly. The main difference is it's orchestrated on the tablet side, just like the move tables and reshard operations are. So then you can do more in parallel. You don't have this VT Kittle or control daemon that has to orchestrate the pieces, which has its own host of challenges. OK. We're over time, 2 minutes over time. I apologize. I stole 2 from the 10 I lost. But these are just some highlights of recent features and features that are coming up. And again, come grab me. I will be at the Planet Scale booth, and I'm more than happy to talk about Vitess, VReplication, Planet Scale. If you are interested, in Vitess, I would encourage you to join the Vitess Slack. It's quite active. I'm in there. A bunch of people on the Vitess side are in there. There's a lot of community members in there, and it's quite active and useful. All right. Thank you, everybody, for joining. Again, come by the booth. You could get a free T-shirt. You can register for some AirPods Pro Max, and you can talk about Vitess if you want.